on the board. The other one has a specified or a specific pole, which is what? South pole. The other end of the magnet has no pole. The other bar magnet has no any pole. So we need to indicate just after understanding the statement, which is just down here. So we are saying when the two bar magnets released, the magnets push away from each other. So now, when the two bar magnets were released, there was that force which was acting between the two bar magnets, which was pushing the other bar magnet on the right and the other bar magnet on the left of our side. So now, what are we saying? What does it mean when this bar magnet pushes the other bar magnet? This signifies to say we are dealing with what we call like poles. Like poles always do what? Repel, and unlike poles always do what? Attract. So now, when we say like poles, examples of like poles, we can say examples of like poles. Examples of like poles are what we call north and what? North pole and what? North pole. These are what we call like poles. And the south and south, these are also what we call like poles. So when we say like poles repel, this simply means that there will be no that attraction between the two bar magnets. Henceforth, the other magnet will push away the other magnet, and the other magnet will also going to push away the other magnet. By doing so, there will be a space that is going to be created because of that force which is existing between the two bar magnets is not allowing them to get attracted to each other. So this is what we call like poles. And when we are talking about what we call unlike poles, when we are talking about unlike poles, what do we mean? Unlike poles normally attract each other. So we are saying unlike poles normally attract each other. So unlike poles normally attract each other. So unlike poles can be north and what? And south. These are unlike poles, and south and what? And north. These are what we call unlike poles. When you bring the two bar magnets having unlike poles, what's going to happen? There will be no end space between the two bar magnets. This signifies to say there is force of what? Attraction. They are going to attract. So this is what you need to understand. So as we're going to come across this particular question which came in 2023 under internal exam for our grade 12s, remember that when when the two bar magnets were released, push away from each other. So question A is saying label the north pole on each magnet shown. Label the north pole on each what? Magnet shown. So how are we going to know that this is the north pole? So we are guided by the other bar magnet. It is given the specific pole, which is what? South pole. And we know to say a bar magnet only contains two types of poles, north pole and south pole. So on the other side, we are going to indicate a north pole this side. Then if there was that force of repulsion, this signifies to say in between there was what we call like poles. So this pole and this pole supposed to be the same. So even this side we are going to have a north pole, and the other side can be concluded to say we can have a south pole to the other side of a bar magnet. So we have responded to question A, which is asking us to find or label the north pole on each what? Magnet shown. So the north pole is this one, and the other pole is what? Is this one. So the two bar magnets are having like poles existing. So there's that force of repulsion existing between the north and the south pole according to the condition of like poles. So write one word which describes what happens to the magnets as they are released. So what has happened to the magnets? So if the statement was saying after they were released together, they had to push away each other. This simply means that the word that we can use is called repulsion or repel. So the two bar magnets had to repel, or repulsion is the word that we are going to use. So we are going to say repulsion. So this is the word that is describing what is happening between the two bar magnets. If you are told to draw the magnetic flux or the directions, you need just to indicate to say the magnetic flux should be like this, even the direction you are even showing how the direction of the magnetic what flux are going. So this is how it should be shown, because the forces we are pushing away each other, and this is going to be the direction of the magnetic what flux. So we have the directions like this. So this is how you need to end your question.